Hello everyone, this is Yuanpei Zhao. My CGT 620 final project is terrain erosion in Voxels. Firstly, let's see project definition. This project is a Voxel version implementation of paper interactive terrain modeling using hydraulic erosion. The outcome will be an interactive modeling of terrains, which contains multiple layers of terrain materials and shows water erosion. The first part of project solution is theoretical part. The basic water simulation method is hydrostatic pipe model. The water field as well as the material height are represented as columns. We generate water height and material height from voxel for each column as initial input. Then we calculate the pressure difference, then calculate the acceleration and the flow of water. Finally, we use flow to modify water height field. After calculation, modify voxels on GPU memory. Then we apply erosion to it. Define M as amount of mass per terrain voxel. At first, the mass equals to 1. When water running over, we decreases the mass by the erosion rate for per frame. If M is less than 0, then the terrain voxels transfer to water, and that is the erosion. Then we add deposition into it. When erosion happens, the mass containing water increases. Then we define an equilibrium sediment mass like this. Note that U is the velocity of water. If the mass containing water bigger than this, the bottom voxel of water column transferred to empty. By doing this, we associate the deposition with water velocity. When water goes fast, more erosion will occur. When water goes slow, the deposition will occur. Finally, we add mass transfer into it. Assume that mass is evenly distributed in each water column. When doing the basic water simulation, we could observe flow exchange F from one column to each of these neighbors. So we transfer equivalent partition of mass contained in those transferred flow to its neighbor. The second part of project solution is CUDA implementation. The simulation and rendering are both implemented fully on GPU, so we use global memory to store everything on GPU. There are cubed n space to store voxel state, and squared n space to store other status. After calculating water and terrain height, we render them using remarching. First, we render front face and back face position to texture using OpenGL, and then we transfer this texture as CUDA array into CUDA. In CUDA, we get the ray start point and end point in the texture and do remarching. After that, we get the color for each screen pixels, and we write these pixels to pixel buffer object and use GL draw pixel in OpenGL to draw it back on screen. The third part of project solution is optimizations. Besides the original material transfer model, add a concentration-based model, which is very alike shallow water pipe model. We compute the outflow based on concentration and then transform them. Also, instead of doing erosion and deposition check every frame, do it every several frames, because water on the boundary has very large volume of material and needs several frames to transport. Now let's see the demo. Firstly, we do the water simulation without erosion, and we can see the transparent water flowing from the top of the mountain to the bottom. And let's do it with erosion, deposition, and mass transfer. we can see the white matter, which is the basic rock, and we can see the yellow sand is erosed. Then the red one is the sand that is deposed. So we could say from here, the water with low speed has a high chance to deposition. And let's see the other two demo scenes. Now, let's see the conclusion. We evaluate the frame per second for different voxel size and the GPU memory usage and CPU usage, and the result is like this. The future work could be in several parts. We could add specular to water rendering, apply textures on terrain to show more realistic results. We could improve mass transfer model and add more layers of terrain. Thank you for watching.